You just need to enable participant screen sharing.
Oh, yes.
Yeah.
Yeah.
Okay, can you see my screen?
Yeah.
Okay, so Yearn, it's a bit of a beast, something I wanted to dive into a while actually, so it was good to get the opportunity to do so. So if you haven't come across Yearn, I'm sure you'll have. It's obviously a sort of an automated yield aggregator or strategy. I just wanted to spend a little bit of time just briefly explaining the core components of the project, because I haven't sort of looked at it before, and it might be useful if you haven't done so as well. And then towards the end, what I'll do is I'll go through one specific strategy, and we can have a look at some code as well. So yeah, for those of you that don't, is this in my way? Sorry. Yeah, if you don't know, so basically Yearn is, there are three sort of core components. You've got the Yearn vaults, the Yearn controllers, and the Yearn strategies. We can briefly have a look at each of those. So vaults are essentially kind of like just simple buckets. They're containers of tokens. So you can see here, this is what the end user will interact with when they use Yearn. So the example, Stefano, I think you're unmuted.
Sorry about that.
No worries. So yeah, here's an example of just a simple DAI vault. So DAI is a token here at the top. You basically put your DAI into this vault, which is just a smart contract. And then as a receipt back, you get something called Y DAI, which just represents your position in that vault, in that contract. So they're the vaults. Then you have something called controllers. And controllers essentially are kind of like the glue. They sit between the vaults here on the left and the strategies here on the right. Now, in V1, each vault could only be assigned to one strategy, whereas in Yearn V2, you can actually have up to 20 different strategies. The strategies don't know about the vaults, and the vaults don't know about the strategies. So the controller is this kind of bit in the middle that sort of decouples the vaults and the strategies. So strategies themselves, what are they? They're really sort of ways of automating things that you're probably doing anyway on the blockchain, but sort of you probably do it manually. So here's a really simple example. So in this example, you have DAI, and that's what they call the want token. So each strategy basically has one token that they're trying to get more of by doing whatever the strategy is doing. So here the want token is DAI. In this example, you would deposit that into the DAI vault, and then the DAI vault would go out and do something with it. And here, for example, it could be deposit that into Compound so that it can be lent out on your behalf. And then what happens is obviously by lending it out, you're getting interest and also probably some rewards. So in this case, comp tokens were obviously one of the first rewards for sort of LP mining that were in DeFi. So what happens basically when you get those rewards is that the strategy will automatically sell those rewards, claim them and sell them on your behalf. So once you get some rewards, you reach kind of a minimum threshold, and then they'll be sold and swapped. Here is the Uniswap, which is why I've got the Uniswap logo. They'll go out and they'll automatically sell those reward tokens to you, which might be, as I say, comp. But here what they'll do is they'll sell those and they'll acquire more of the want token, which in this example is DAI. So they'll be selling comp for DAI in this example. And then when you've got some more DAI, what you'll be doing is you'll be reinvesting that back into the strategy, and the whole thing loops. So you're kind of just going round and around and around, amassing more of the want token. So that's just a really basic strategy. So yeah, so basically on the vaults, you have a function called earn, and that's how essentially you sort of kick the whole process off. So what you would have is you would have the earn function be called by the vault. It interacts with the controller, which will then call the deposit function on the strategy. And then at that point, you interact with this third-party DeFi protocol. Another important function is the harvest function. It's contained within the strategy, and we'll see that later on one specific strategy. As the name suggests, harvest simply is essentially claiming rewards. So in our example earlier, you'd be claiming comp tokens. So you can see here that harvest is called in the strategy contract. You then claim these rewards from the DeFi protocol. They are sent back. You're then swapping those rewards here for the want token. You see here using Uniswap, you're swapping that for the want token. And then here's the loop. So you deposit that back into the strategy and the whole thing starts again. So kind of strategies, how do they work? There's loads of different strategies, and I find it sort of quite hard to unpick it a little bit because the code base is quite long, as you'll see. But some key things to note is that each strategy inherits from base strategy.sol. The base strategy, as you can see here, basically implements the sort of core requirements to get them to be interoperable with the various vaults. In this base strategy, what you're doing is you're essentially calling a few different functions. So you're calling this harvest function that we talked about earlier as being really important. And you can see that it recognizes the profits and the losses of the strategy and adjusts the strategy position. So what is this function? We'll have a look at the specific code in a minute, but the main things it's doing is it's calling this vault.report function, the prepare return function, and then also this adjust position function. These are what I can see as being three of the key things that base strategy does. So moving on to a more specific strategy, this is one that I chose to focus on. The reason why I focused on this is because it was recommended in the Discord as a good place to start. But also it's quite simple, so they can get quite complex. So for example, Curve is used quite a bit in Yearn, and the Curve protocol, if you really get into the nitty-gritty, is actually quite complex. So I kind of wanted to avoid those ones and just do something really, really simple. I've also done this specific strategy myself manually, but one thing to bear in mind that's really sort of useful about Yearn is if you've got 1,000 different people all doing, a small trade, doing the same strategy, maybe with $1,000, each one of those people are paying the gas fee every time they want to claim the reward tokens and then reinvest it back in. It kind of doesn't really make sense. So with Yearn, it's really kind of like a scaling solution as well. I've heard it be described as, because obviously those 1,000 people could pool their funds together and then only pay one gas fee. So you're kind of socializing the cost of the transaction fee. So kind of makes a lot of sense for these strategies and these actions that are being performed kind of again and again and again by lots of different people to kind of lump those together and get some efficiencies. So the strategy that I chose to focus on is called Yearn Aave. There's a really good website called yearn.watch, which has a really cheesy picture of Baywatch. What's his name? The Hoff from Baywatch. It's kind of there. But the point is, it's got all of these strategies, and you can kind of see which ones are popular and stuff. So that's a really good site if you're interested in finding a different strategy. But yeah, this one's called Yearn Aave, which I think basically stands for general leveraged on the Aave protocol. So what is this strategy? Very similar to kind of what we described earlier. So what we're doing here is we're depositing collateral, so that's our want token, into Aave. Now, I'm sure you all know Aave is obviously a borrowing and lending protocol. So when you deposit, obviously Aave will lend those tokens out, and you'll get rewards and interest for doing that. Now, what happens here is rather than just, let's do an example. Let's say you want to deposit 100 DAI, rather than just doing it once and then earning, say, 10%, for example, as your interest for doing so. What they're doing here is they're depositing the 100 DAI, and then they're levering that up to, say, 75% loan to value, something like that. And then that would obviously be borrowing another 75 DAI. And rather than stopping there with that additional borrowing that you've got, so the 75 extra that you borrowed, you then go and deposit that back into Aave. So now your collateral is $175. And then obviously you can borrow against that and redeposit again. You kind of run this loop around again and again, up to 8 times, I think, in the strategy. Each time your LTV goes down, obviously, because you can only leverage up to a certain threshold, less than 100, so probably 75%. So there is a limit on this strategy, and you can't loop ad infinitum. But obviously, what you're doing here is you're kind of getting a much bigger collateral base. Why would you do that? Well, you're introducing more risk, but obviously your rewards are higher as well because your deposit base, your equity is higher. So therefore your reward tokens and your interest is reflective of the higher amount of collateral you've got deposited. So that's what the strategy is doing. Let's have a look at some code. So as I said, it's pretty big.
Sorry,
pretty
I have
big. Oh yeah, go ahead. Yeah.
I have a question. So this strategy is depositing Aave token into Aave and borrow what token? Is it borrow Aave?
So I don't think it needs to just be Aave. I think it could be a number of different tokens. So that's the want token. But I think where Aave token itself comes in is you get some rewards. So rewards for doing that, I think at the time were Aave tokens for depositing into that. So the important thing to bear in mind is you're borrowing the same token as you're depositing. So if you deposit DAI, you're borrowing DAI. So you're not borrowing, say, Aave, because then that would be some weird kind of cross collateralization risk where the price of your deposited asset and your borrowed asset can get out of kilter. So if you think about it here, there's kind of no real way to get liquidated. So if you're depositing DAI and you're borrowing DAI, clearly your 75% liquidation threshold can never be hit because your borrowing base and your lending base are in the same token. So the whole thing will go up and down together. So it's a very safe way of borrowing. Because if, for example, I deposit, ETH and borrow DAI, if the value of ETH falls and DAI stays the same, then obviously I can get liquidated because the value of my collateral is going down in DAI terms.
Okay, but usually borrowing cost is higher than depositing, the interest on depositing, right?
Yeah, but you'll get rewards for doing so. So I think at the time, I don't know, you would have got probably, 20-30% probably for borrowing. For borrowing. In Aave tokens, there would have been some kind of incentivization mechanism that makes the whole thing economically worthwhile doing. But otherwise, you wouldn't want to loop and pay more on the borrowing than the lending or the depositing side. Exactly right. Yeah. I guess it's probably why this strategy actually isn't used that much anymore, because I'm guessing as Aave has grown, the rewards for doing that have probably come down. So I think this is still going, but it's sort of, I don't think there's a huge amount of money deposited into it. But as I said, I wanted to focus on it because it's pretty simple. And it was recommended by the Yearn guys as a good kind of first strategy to take a look at.
Okay, thanks.
This strategy starts on line 2750 onwards. So that's here. So we can see. So contract strategy, 2,700 lines down already. But yeah, strategy starts here. And you can see here we're inheriting from this base strategy. Base strategy is further up here, but if you want to take a look at it, obviously you can a bit later. But just focus on some more interesting parts. So I want to have a look at these two main functions. So prepare, return, and adjust position, which are kind of the most important guts from what I can see and kind of power the whole thing. So 3014. Let's just have a quick whiz through first, and we'll go down to that function. So what happens first? Really, you've just got a bunch of variable declarations first. So you've got these different token addresses, the different controllers, the Aave, the uni sushi and Uni v2 and Uni v3 routers, because obviously you need to swap your rewards into your want token. Nothing too interesting here. So the constructor calls initialize this, which really just sets all of the variables here. So these are kind of parameters to the various things that we're doing here. So you've got various fees. So they've got limits on like when they want to swap things. So fees are too high, etc. Minimum amounts to bother collecting for reward amounts, etc. Yeah, this is all pretty generic. Okay, so I think the first bit that gets a bit interesting is this prepare return function. So remember, this is called in base strategy.sol. One of the main things it's doing is essentially claiming and selling your rewards. So you can see here on 3024, we call this function underscore claim and sell rewards, which sell rewards starts on 3218. So let's have a quick look at that. 3, 2. Yeah, it's here. Claim and sell rewards. So there's some sort of complications in this. There's things like cooldown periods on these RV rewards that they're kind of checking to see whether they're in a cooldown period or not. But I don't fully understand all of that. The guts of this really is here when you're selling your RV, which is your reward token for your want token. So you're kind of saying here, okay, get the balance of the RV rewards if they're greater than the minimum amount that you want to sell, which is a parameter that we set earlier, then you're selling your RV for your want token. So that's obviously harvesting the rewards and then getting more of your want token, and then later on they deposit that back. So back up to 3014.
I have a question.
Yeah, go ahead.
There was I think it inherited Flash receiver. And there's some reference to using flash loans. How does that get involved in the whole strategy?
I didn't have time unfortunately to look into that, but this strategy does use flash loans, I think, as well. But the code base is quite big, so I didn't necessarily look into that. So yeah, I wasn't too sure, to be honest.
Yeah, 3,000 lines seems massive.
Yeah, I mean, it's quite complex and there's lots of flexibility in it. But I mean, it does boil down to a few of these functions that I was going through. Obviously, there's a lot more devil in the detail, but I feel you could spend a long time kind of really fully understanding this. So in this prepare return function, you're claiming and selling your rewards, and then you're kind of saying, well, so what is this? Yeah, they're checking their debt positions. So they're basically saying if the amount of the required repayment is greater than the amount that's available, then they're in this kind of negative equity position. And then they need to sell some of the position. So they're liquidating some of their position to bring back these collateralization ratios, because they've got sort of health factor thresholds that they have to keep within. So that's kind of the main thing that's going there. Essentially claiming your rewards and kind of running a bunch of accounting health checks on the amount of debt versus the amount of equity, and adjusting the position if any of those are sort of at an uncomfortable level. And then the other major function that's worth looking at is this adjust position function. So again, you can see this was called in, it's called in the base strategy. Adjust position, what's this doing again? again, it's sort of checking your current position, and it's applying these current collateralization ratio versus the target collateralization ratio. And it's saying if you're below the target, what you want to do is you want to loop again. So you want to call this lever max function, which does another loop of the borrowing and depositing cycle. And then if you're over that threshold, so if your LTV is higher than your target LTV, then you're levering down. So it's kind of, yeah, the first function here, this one, prepare returns, is kind of claiming your rewards and swapping them back out into the want token. And this second function, adjust position, is making sure you're within the target LTV collateralization ratios, and then levering up or levering down based on that. So that's kind of as far as I got, really. Yeah, the code base is pretty big. But yeah, that's as sort of all I want to say, really. That's kind of as far as I got. Happy to sort of answer any basic questions, but yeah, that's kind of what I was hoping to present.
Does it have any function that checks the borrowing rate versus the deposit interest rate?
It's a good question. I mean, it must do.
Yeah, I imagine it should have, right? Because if it's not economical to borrow, then it's not worth doing it.
Yeah, you're right, exactly. I wonder if we can find that in the where's the beginning? 2.7 in the variables at the beginning. So here we are. Addresses, supply and borrow tokens, cool down, swap routers, state variables. See, default collateralization target margin. These kind of sound like interest rates. Yeah, I'm not sure. There must be somewhere in there. But I don't fully profess to fully understand this whole strategy. Yeah, it's quite tricky to unpick it all. Yeah. I don't see any other interest rates in here, but there must be somewhere.
Yeah,
Maybe I'm missing
doesn't
something.
look like there is, right?
Yeah, it's a bit odd though, isn't it? Maybe it happens in the controller, but that would seem strange though, right? It feels to me like logically it would obviously reside here because those rates are clearly moving in line with the market. So hang on, max bips wanted ratio. That's doing. Yeah, this is more to do with the price impact, I think, of selling things. So slippage. This is like a slippage check. Yeah, not too sure, but as you say, must be in here somewhere. Yeah. there any other questions or anything else we wanted to look at? We could look at base strategy, I guess. Have a quick look through that. It's interesting.
Yeah, let's have a look at the base strategy.
Here we are. So base strategy, how does this work? Base strategy implements all of the required functionality to interoperate closely with the vault contracts. This contract should be inherited and abstract methods implemented to adapt the strategy to the particular needs it has to create a return. Of special interest is relationships in harvest, vault.report. Yeah, that's what we talked about. Okay, so that's just API version. It's the name of the strategy. Okay. So there's a few different actors, obviously, that are involved in here. You've got the vault itself, the strategists, the rewards, and the keeper. Not totally sure what the keeper does, but I think on this slide, which is from Yearn themselves, you can see that so the strategist calls harvest. That's the keeper. Yeah, keeper bot is calling earn in the vault. So I'm guessing he's the controller of the vaults. This is your want token. Bunch of sort of setters for the various addresses, the various actors that we need to make the strategy work. Bunch of modifiers. Where's the constructor? Constructor called initialize. Why is the want is not equal to zero address? Just sets a bunch of variables. This is used to change the max report delay, which is the maximum number of blocks that should pass before harvest is called. Okay, so this is sort of when you harvest your returns and you do another loop.
Oh, I think keeper's job is to harvest the reward, right? For external keepers, this is the maximum time between jobs to wait. See harvest trigger.
Where is this one?
Yeah, also, if I'm not wrong, I think the keeper's job is as well to check if the strategy is profitable in order to allocate it a certain amount of the tokens disponible in the vault. So maybe that's why they don't check for whether the strategy is profitable within the strategy code. So it's done externally by the keepers or.
Right.
I guess the only issue with that, I suppose, is it's dynamic, isn't it? So, I mean, it can be profitable for 1 hour and then an hour later, it could be not profitable. So I guess it needs to be done, I would imagine it needs to be done programmatically. Because as you obviously deposit more into Aave, then the rates charged and paid to depositors is obviously dynamic. I'll ask that question. I'll get back to you guys. Yeah, I can ask in Discord. I've been speaking to the guys.
You can see the line 1944. It says the maximum number of seconds to wait between harvests. So I guess this is the kind of frequency that they set to check the profitability, right?
Yeah, I guess so. I wonder sort of how often it's done, actually. I'm not totally sure. Is it done like every I guess once you've reached the threshold, because there are minimum thresholds, you wouldn't want to claim one DAI and pay a 100, you know, 100 DAI transaction fee. So I would have thought it was all done programmatically, but yeah, I don't know. Oh, here we are. Look, used to check profit factor. Profit factor is used to determine if it's worthwhile to harvest, given gas costs. Okay, this is more of a threshold kind of thing. There should be another check to see whether the overall strategy is profitable. Profit factor is a ratio multiplied by anticipated harvest gas cost. So sets how far the strategy can go into loss without a harvest and a report being required. Okay. Estimated total assets. Provide an accurate estimate of the total amount of assets, principal plus return the strategy is currently managing. Is active check. Yeah, here's the prepare returns that we looked at earlier.
So why is the, sorry, can you go back to the prepare return, please?
Yeah. Yeah.
So it's
the actual implementation, or
it's set to internal. So does that mean, so how can someone call that function?
what does internal do again? Remind me of what that does. Is it only called within that contract?
Yeah, internal is function that can be only called within the contract, but by other well, you can have other functions that call that function within that contract, but you can't have an external contract or address that calls the function.
Yeah. Isn't this like, yeah, would that also apply to like, I'm not sure is the answer. Is it only internal in the contract where it's implemented? Because obviously this is just
I think maybe you can
this is not an implementation, right? This is just the signature. So
yeah, maybe can have a look at the implementation.
this is what we looked at earlier, right? This is the prepare returns. So you can see it down below. Yeah, it's hit implemented here. So I suspect it's okay to be in, it's only internal to the contract in which it's implemented, I suspect is the answer, and it's implemented in this contract, which is strategy.sol. So it can be called within strategy.sol, I guess. Kind of. Does that make sense to you or not? Not really. I mean, I can ask the guys. But that kind of seems to be what's going on.
Because I thought this function is used to check how whether how much profit or loss is that strategy when by an external address or contract.
So this is the main function is the claim and sell rewards. That seems to be the main thing that it's doing. And it's
it has to realize it has to claim the rewards to know how much reward it has earned, right?
Yeah, but I guess to your point earlier, there should be another check going into the strategy as to whether the kind of, you know, borrowing and lending rates kind of plus rewards make sense to do this, right? There's another check, obviously, where you're saying, well, should I bother claiming these rewards? Are they over the threshold of the gas fees and to make it worthwhile? So I guess there's two kind of profitability checks. There should be anyway. One for the claiming rewards and one for should we be in this strategy in the first place.
It doesn't look like it has.
I know, yeah.
Because as far as I know, this prepare return is the function that you the bot, I think it's the keeper bot, calls to see whether the strategy is profit or loss.
Okay.
But I don't know if it's internal, how can it call? Maybe there is another function within the contract that calls that function.
Prepare return. Let's have a look. What is it called? It's called here in the harvest function.
So on
Harvest
keeper,
only keepers, they are. Yeah.
Exactly, yeah. So keeper will call that harvest function, and then harvest function will call prepare return. Okay.
Yeah. So harvest is in which contract? That's in base strategy. So base strategy can call prepare return because it's internal to that. But the implementation is in strategy.sol. Yeah, it's an override as well. So it's, yeah, presumably it's still okay to call an internal function, is it? I guess from another.
Well, strategy
something.
also inherits the base strategy, right?
Mm-hmm.
I'm sure there is a harvest return, a harvest function within that strategy contract.
Quite a few comments. So that is within base strategy. I can't see it. Because strategy only starts at lines 2750, so it's not in there. The last one's here. It's only called once in here.
Well, I guess because the strategy contract inherits the base strategy, so it will have the harvest strategy harvest function as well. The contract, because the contract inherits the base strategy, so it will have all the functions that are available in the base strategy.
Are you able to call an internal function though? If you inherit from base strategy and there's a function declared as internal in base strategy, are you able to call it in the contract that's inheriting the sort of child?
Yeah, you can. Well, external contract cannot call the internal the function that is marked as internal, but within that strategy contract, you can call internal functions.
The internal function can be called within the so like if contract A inherits from contract B, contract A can call an internal function in contract B, but it can't call a private function in contract B.
Okay, that makes sense because it is calling something that it's inheriting from, a function in a contract it's inheriting from. Yeah. Yeah. Is there anything else we wanted to have a look at the base? We're still in the base strategy, weren't we? Should we go back to that? Base strat. Where were we? setters. Prepare returns. Okay, yeah. Oh, no, we've gone into the next strategy now, haven't we? Sorry. Where's the main? Yeah. Okay, so there's the prepare return signature in the base strategy. Adjust position. This is the other important function. Internal virtual. Okay, because it's overridden in the strategy .sol. Liquidate position. Yeah, I think that's called in the adjust position function. Liquidate up to the amount needed of the want of this strategy's positions, irregardless of slippage. Any excess will be reinvested with adjust position. This function should return the amount of want tokens made available by the liquidation. If there is a difference between them, loss indicates whether the difference is due to a realized loss or if there is some other situation at play, e.g. lock funds, where the amount made available is less than what is needed. Liquidate all positions. I guess that's some sort of emergency kind of thing. Tend trigger. Provide a signal to the keeper that tend should be called. The keeper will provide the estimated gas cost that they would pay to call tend. And this function should use that estimate to make a determination if calling it is worth it for the keeper. Okay. This is not the only consideration into issuing this trigger. For example, if the position would be negatively affected if tend is not called, then this can return true even if the keeper might be at a loss. Okay. So tend calls the adjust position that we looked at earlier. There's the harvest function we looked at.
What's the difference between harvest trigger and harvest thing?
This is harvest trigger.
Harvest trigger.
So harvest trigger is, what's it doing? So this is the cost, I guess, to do the swap. Calculates the outstanding debt. Check for profit and losses. Total is estimated total assets.
Okay. So this is to determine whether the function, the harvest should be called.
Yeah.
If it's profitable, then it will call.
Yeah, I think that's right. Otherwise, only trigger if it makes sense economically. Gas cost is percent of value moved. Okay. Yeah, it's like a check, I guess, to see if it's worth calling harvest. Yeah, some kind of emergency check where you liquidate all positions, otherwise prepare the return, which will claim the rewards and reinvest them. And then it's sort of saying, okay, do we need to lever up or lever down? So it calls adjust position, which will lever up or lever down. Harvested event. Withdraw. Migrate. Emergency exit. Protected tokens. Removes tokens from the strategy that are not the type of tokens managed by the strategy. This may be used in case of accidentally sending the wrong kind of token to the strategy. Okay. Okay, yeah, that's the end of it. This is a different interface.
Okay.
Yeah. So yeah, it's not super straightforward, but still, I think useful to have a look at it. I guess they're trying to keep it kind of pretty generic, so they can adapt strategy.sol to individual strategies, of which there are, I think there's 88 or something when I checked Yearn. There's quite a few of these, and they obviously come in and out of sort of vogue as to whether they're sort of profitable or worthwhile doing.
Okay, anyone else have any questions? If not, we can end here. So for next week, anyone else? I know Dan is going to present on fractional NFT. I don't know if anyone else have any other ideas.
Didn't we want to do? Is fractional NFT is like a leverage platform? Is it get borrowing against your NFTs? Is that right?
No, the idea is that you can each person owns a small pieces of an NFT.
Okay.
Because currently you can only buy NFT as a whole. You can't.
Yeah, for sure.
Yeah.
Got it. Yeah. Didn't we say we're going to look at rare? We did Rareable, did we?
We did last week.
We did. Okay. Yeah. Sorry, I didn't make it. Okay.
I'm thinking about presenting on smart contract upgrades. If you guys think it's interesting.
How to make it upgradable?
Yeah, exactly. So there are a few approaches to upgrade a smart contract, and each has their own kind of pros and cons and potential security issues. So I thought it's interesting.
I would be very interested in that. Yeah, sounds interesting to me.
That would be cool. Like if anyone has an idea of something he wants to present, that's cool too. Like we don't have to have a specific protocol or subject. If someone is hot for something.
Yeah, sure. Yeah, anyone, if you want to present on any topics that you think is interesting, please feel free to put in a WhatsApp chat.
I mean, does it have to be a smart contract system? Because there's this paper on TWAP Oracle vulnerability that I wanted to dig into, and I don't know if that was a valid topic to discuss, because it's not like a smart contract, like some protocol to look at.
What's the article about? TWAP?
So TWAP's like, it's Delphi Labs presents attack cost and profit from manipulating constant product market maker TWAP oracles and DeFi protocols.
Okay. Yeah, I think that will be interesting. I think because that is basically impacting the DeFi protocol, right? Is I think it will be also interesting topics. I'm actually also thinking about. I haven't had time, but I want to dig into how stable coins are. How do they make stable coins work? There are a few ways of kind of the mechanics of stable coins.
Yeah, it's very, very interesting. That it's a deep topic, actually. You've obviously got like UST, and then you got Frax, and there's lots of interesting algorithmic ways to make it work. But I think it's super interesting topic and really important, really important. It's one of those head scratches, isn't it? I mean, even looking at like UST and Luna, like thinking, how on earth is that actually like actually working? But it seems to be working, right? I mean, they've held their peg pretty well. So yeah, I think that's a super interesting topic.
But there have been cases where stable coins have failed. I think last year, I think in June last year, there's a stable coin called Frax.
Yeah.
Which actually could not hold the peg and failed. So it would be interesting to do a case study to see which one works and which one doesn't, and why don't they work.
I think it's super interesting. Yeah, I mean, a lot of this has come out of, I think people don't think DAI is very good. So if you look at like UST, Do Kwon, who's like the founder of Luna, it's actually his Twitter nickname is at Stable Kwon. So he's all about like stable coins. And yeah, he's kind of wrote this article. Let's try and dig it out actually if people are interested, but sort of saying why DAI is this sort of poor instrument. And there's this kind of reflexivity to it, that when you need things to be stable, that DAI isn't stable because there's no demand to borrow to go long. I forget the main arguments, but yeah, that's kind of why he invented the whole Terra ecosystem. Because obviously DAI is pretty much the first, like, you know, crypto native stablecoin that's sort of decentralized. So yeah, I think kind of a lot of these have sort of started with DAI not necessarily being the best, or they didn't think it was, and they're trying to iterating on that and then trying to improve. And but yeah, I mean, a bunch of experiments, right? I mean, even UST itself, I think, went down to about 92 or so cents per dollar, or sorry, per one UST last year. So they've had issues as well. But I think they've recently made a bunch of different changes to the protocol, how it works. And I think during the last big sell-off, it performed really well. So I think that'd be a really interesting topic. Yeah, I would definitely be keen to, yeah, help you out if you want to have a look into that.
Yeah, sure. Okay. Thank you everyone for your attendance. We will see each other again next week.
Thanks for organizing.
Thank you.
Yeah, thanks, Ben, for presenting.
No worries. Thanks.
Thank you, Ben.
Thank you. Bye.
Bye.